Hello everyone, this is Rhittick Kashyap, a faculty of physics from Zero, the Learning Lab. Today we will be starting our first class, beginning with the topic motions in a straight line. First of all, what is motion? যেতিয়া আমি motions বুলি কওঁ, motions means the change of position of an object with respect to time. Correct? Now, motions are basically of two types. One is kinematics, kinematic study of motion, and next is dynamics. Kinematic means the branch dealing with motions without going into their causes. As for example, it doesn't relate with why does the motion happens. Motion to kihor karone hoy aru yar cause to ki kinematics ami hetu define koribo nalage. Aru dynamics kore ki je motion goes to their causes. Motion to kihor karone hoise hetu amak dorkar hoy. Hetar amar relation to dorkar. As for example, Newton's laws. Or yet motion in a straight line, or yet plane. Newton's laws, inertia, work, power, energy. Etc. Kinematics deals with the motion without cause going into their causes, whereas dynamics deals with the causes of motion. Clear? Motion man ami ki palo the motion is nothing but a relative change in position of an object just with respect to time. Clear? Jihetu motion kotha aise, motion kotha hogar ami tinta bostu gom pabo lagibo. First hole for to one dimension, second hole 2 dimension, and third hole 3 dimension. Now what is one dimension? Ami janu je amar asot tindal axis ase, right? Say this is x, y and z axis. Hol jedi one dimension hobo jitu bostu jedi ami kiba eta object bujabor karone amar jikono edal axis amar byabohar kora hoy. Say either of x, y or z axis. And motion along this line in any of this line is one dimensional motion. Clear? As for example, motion of a train along a straight path, free fall under gravity, etc. Next, two dimensional motion. What is two dimensional? If any of the two coordinate axes are required, x, y, z, যদি আমাৰ এই x y z ভিতৰত যদি যিকোনো দুডাল এক্সিস লাগে আমাৰ কিবা এটা বডিৰ পজিশন ডিফাইন কৰিব কাৰণে তেতিয়া হলে তাক কোৱা হয় two dimension, and motion along it is known as two dimensional motion. As for example, an insect crawling on a floor, a car moving in a zigzag path. Well, say ইয়াৰ এটা পইণ্ট আছে, এই পইণ্টটো ডিসক্ৰাইব কৰিলে আমি কি হ'ব, আমাক দুটা পইণ্ট লাগিব, say up till x and y. So this is your two dimensional motion. Motion in a plane is an example of two dimensional motion, and motion in a straight line is an example of one dimensional motion. Clear? Next is your third dimension. Now what is that? If all three axes are required to define a point, then this is known as three dimensions. Say a point in a space required all three axes to be defined, and motion along all three directions is known as three dimensional motion. Clear? As for example, a flying bird and flying aeroplane, etc. Clear? Next, as you can see in the above all examples, first dimension, second dimension, third dimension, I have never mentioned about the size and dimension of the object, right? I have just said it, just an object moved along the axis, or an object moved along the plane, or an object moved along the space. But here now comes the concept of point object. Now what is point object? Let me define it. The motion of an object when ignored the size and dimension of the object, it is regarded as point object or a particle. যেতিয়া আমি এটা অবজেক্টৰ মাছ আৰু ডাইমেনশন সে সাইজ এণ্ড ডাইমেনশন যেতিয়া আমি ইগনোৰ কৰোঁ while describing its motion, তাকে কোৱা হয় that object is referred to as a point object. In other language, when an object covers a large distance as compared to its dimension, it is generally considered as point mass or point particle. Say এখন বাস আছে, এখন বাস A ৰ পৰা B গৈছে, হল AB length আছে মই কৈছো তোমাৰ 300 কিলোমিটাৰ, আৰু বাসখনৰ length মই কৈছো তোমাৰ hardly কিমান 10 মিটাৰ 20 মিটাৰ আছে. See, the dimension of the bus is far more less than the distance between the A and B. Correct? In this case, this bus is referred to as point mass. Point mass or a particle. Clear? I am repeating it. What is point object? When describing motion, we ignore the size and dimension of the object. Those objects are known as point objects. Well, similarly, it is also related to point mass. See, the bus has some mass, correct? And the size and dimension of the bus, say it's about 20 meter, and distance it will travel, say 300 kilometer. The distance travel between A and B is 300 kilometer, which is far more than the dimension of the bus. In this case, this bus is regarded as point mass or a particle. Clear? Next we are going to start types of motions. There are basically two types of motions. Types. Number one, translatory motion. Translatory motion. And number two, rotatory motion. In the translatory motion, when every particle of a body travels the same distance along the travel path, irrespective of its path, say it may be straight or curved, such motion is known as your translatory motion. Say a car traveling in a path, a car traveling in a road, car in a road is an example of translatory motion. Clear? Rotatory motion, say motion of planet, whenever a body turns about a fixed position or axis, such motion is known as rotatory motion. Rotatory motion example I have said it, revolution of planets, and translatory motion example, a car moving in a road, In this case, we will be studying only your translatory motion. Rotatory motions comes in your next chapters. Again, the combination of two is also possible. A combination process, example, say a ball rolling down an inclined plane. This is your example of both translatory motion and rotatory motion. How? কেনেকৈ হ'ল এইটো? যেতিয়া এটা বল এখন সাৰফেসত ৰোল হোৱাৰ মানে কি? It is a rotatory motion. It is changing a position from one place to another. Correct? It is moving in a যেতিয়া roll is a point A to B. যেতিয়া point to A এর পৰা B লে আহিছে মানে কি? It is transmitting its position with respect to time, which means it is translatory motion. Correct? Again, the ball is rolling with respect to its itself axis. Correct? So it is your rotatory motion. This type of motion will be reading in work power and energy. Clear? So in our next class we will be starting the distance and displacement concept and various graph relations.